if x plus y upon ax plus by is y plus z equals to ay plus bz equals to z plus x upon a plus az plus bx, prove each of this ratio is equals to 2 upon a plus b if x plus y plus z equals to, unless x plus y plus z is 0. Let's try to understand this. So here what comes to my mind is, we have learned if a upon b is c upon d equals to e upon f, which implies that a plus c plus e upon b plus d plus f. So each of this ratio should become equals to this. We just saw that. So if someone is telling me if x upon y upon ax plus by is equal to y plus z upon ay plus bz equals to z plus x upon az plus bx, doesn't it mean that all these ratios also should be equals to, I add all the numerators, then it becomes 2 times x plus y plus z. And if I add all this will become ax plus bx plus by plus ay plus bz plus az. Yes or no? Which means if I simplify this, 2 times x plus y plus z, I take x a plus b plus y a plus b plus z a plus b. Correct? If I take a plus b, y common here, x common here, z common there. So this will become 2 times x plus y plus z. And here I will take a plus b common. So it will become x plus y plus z. Now x plus y plus z cannot be 0, because they have told us that if it becomes 0, then this ratio is not defined, because something divided by 0 is not defined. So if it is not 0, I can cancel this out. Then each of these ratios will become 2 upon a plus b, which is what they have asked. So if this is equals to this is equals to this, which implies addition of all numerators and addition of all denominators also should be equal to this, which means 2 upon a plus b. So we proved this. Okay. Again, this sum can be solved through componendo and dividendo. So this I will try to give you in homework. Just try to do that in homework. So the next sum is, if a upon b plus c is equals to b upon c plus a equals to c upon a plus b, then prove a upon b plus c equals to b upon c plus a is equal to either half or minus 1, which means each of these ratios either equals to half or minus 1. So let us try to understand. A upon b plus c equals to b upon c plus a equals to c upon a plus b, which means each of these should be equal to a plus b plus c upon 2 times a plus b plus c. We have seen this theorem. Now, there are 2 scenarios. I will take 2 cases, case 1 and case 2. In case 1, let us say a plus b plus c is not equal to 0. And in case 2, I will say a plus b plus c becomes 0. Okay. So if a plus b plus c is not equal to 0, then in that case, I can cancel this out. And this ratio will become half. Which means the first part I have proven, it is equals to half. Now let us say what happens if a plus b plus c becomes 0. In that case, this ratio will be a plus b plus c. Okay. Which means a plus b is equals to minus c, b plus c equals to minus a, and a plus c equals to minus b. Does it mean that? Right? Which means this ratio will become a upon b plus c equals to b upon c plus a equals to c upon a plus b. I can write it as, instead of b plus c, I can write it as minus a. Instead of b upon c plus a, I can write it as minus b. Instead of a plus b, I can write it as minus C. So minus 1 equals to minus 1. Each of this ratio became minus 1 in the second case. So hence we have proven it. Okay, next. Okay, another similar sum. So we have AY minus BX upon P equals to CX minus AZ upon Q and BZ minus CY upon R. Then again we will ask the question whether this X upon A equals to Y upon A equals to Z upon C is true or false. Okay, so if you see here in the previous sums, the numerator and denominator, all the three quantities, they were actually symmetrical. But here there is another term PQR which is missing out from the numerator. So how do we do it? So let us try to make it symmetrical. So here it is A and B. So I'll try to multiply and divide both the sides, both the numerator and denominator by C. We'll see what happens. So this will become CP. Here I will try to do it by B. This will become BQ. And here I will try to do it by C. I'm not changing the ratio, right? Because I'm doing the same effect on numerator and denominator. So now this will become ACY minus BCX upon CP equals to BCX minus ABZ upon BQ is equals to BCZ minus, so this will be by A, not C. So this will be ABZ, because here it should be by A, not C. So I had by mistake done C. So ABZ minus ACY upon AR. So now if these three quantities are equal, now this is looking a little symmetrical to me. So now I will try to add this. So when I add this, ACY and this ACY will get cancelled out. BCX and this BCX will get cancelled out. ABZ and this ABZ will get cancelled out. So this will become 0. CP plus BQ plus AR, which means the entire ratio actually became 0. 0 upon something is always 0. Which means this entire ratio actually is equal to 0. Yes or no? Which means AY minus BX upon P is 0. CX minus AZ upon Q is 0. And BZ minus CY upon R is also 0. AY minus BX, if I take P on that side, AY minus BX will be 0. CX minus AZ will be 0. And BZ minus CY also will be 0. So from here I get AY equals to BX, X upon A equals to Y upon B. So this is what result I get. From here I will get CX equals to AZ, which means X upon A equals to Z upon C. Now X upon A is equals to Y upon B, and X upon A is also equals to Z upon C, which means X upon A is equal to Y upon B, which is equals to Z upon C. So this condition is true. Answer is true. Okay. Hello students, this is Aalok Guptaa, your mathematics mentor and coach at Kkhyatis EdTech. So I have brought a lot of problems around 120, 130 on ratio and proportion. Please go through it, and if you have any queries, please get in touch with me on WhatsApp or subscribe to my YouTube channel. I'll be getting motivated and I will come with more and more such concepts in near future. Thank you so much.